Okay, so I'll be going through this question 12 first. Here we always have to understand the question before we can start tackling it. Always start by understanding, come up with a plan, follow through with your plan, and check your answers. So here we have biscuit. It's a cuboid. This is our biscuit. It measures 4 by 4. Okay, so since the sides are 4 by 4, this is going to be a square. And the thickness of this biscuit is 2 centimeters. For this biscuit, I can pack 20 of them either in this manner. So I've got 10 of them, 10 biscuits at the side. The other way of packaging it will be stacking all 20 of them in one row. So find the values of x, y, and z. In part A, x is going to be 4 plus 4. So the value for x is 8. Because the length of each side of the square is 4 centimeters. Putting them side by side, we get 8. Next, the value of y, over here. Since we know that there are 10 biscuits. Because we have a total of 20, we divide them into 2 groups. So there must be 10 on one side. So 10 times 2 cm, we get 20. So the thickness in packaging A will be 20 cm. Whereas for packaging B, our Z value will be 20 biscuits times 2 cm, and we get 40. Now part B. Find the total surface area of the outside of each packaging. Let us start with packaging A. To find the total surface area, always start by shading the cross-sectional area. The cross-sectional area is the area that repeats itself all the time. In the case of a cuboid, we have 3 possible cross-sectional areas, but I think most students will choose this to be the cross-sectional area, because that's the one that's facing them. Okay, if you chose this, please shade this also. Now after you have shaded this, the formula, I'll write down the formula again. For total surface area. Equals to 2 times of the cross-sectional area. Okay, so we got 1 in front and 1 behind. That's why we have 2 of them. With plus, open bracket, perimeter of cross-sectional area. It is the same cross-sectional area that we have shaded over here. So the perimeter over here, later I'll outline the perimeter for you. We're going to multiply this by the thickness. And this is the formula. Okay, let's start. 2 times of the cross-sectional area. X, we found that it was 8. So this shaded area is a rectangle. The formula for area of a rectangle is length times breadth. So 4 times 8. Okay, I'm just following the formula. Next we add. See the plus over here? Plus. Now plus the perimeter of the cross-sectional area. This is the perimeter. Okay, I've highlighted the outline. I've outlined the perimeter. So this perimeter is given by 8 plus 4 plus another 8 plus another 4. Okay, no different from our perimeter in primary school. For a perimeter of rectangle, no difference. It's the same thing. Here we still need to multiply by the thickness. So how thick is this cuboid? Given that the shaded area is my cross-sectional area, then it has to be the 20 over here that was not used. This is the thickness. Multiply this by 20. Key everything into your calculator to find out the value. 2, 4 times 8 plus, open bracket, 8 plus 4 plus 8 plus 4. Multiply this by 20. So we get 544. Okay, keep putting the units. And this is the total area for packaging A. Do the same for packaging B. Okay, right now I'm going to erase my answer for packaging A. So part B, area for A equals to 544 square centimeters. Okay, we're going to be using that later on. So now I want to find the total surface area for packaging B. It is going to be the same formula. So first thing, where is the cross-sectional area? Most likely, you will choose this square. So what is the formula for this area? 4 times 4. Okay, so we copy down these two over here. There are two faces, one in front and one behind. So that's where this 2 comes from. Now cross-sectional area will be 4 times 4. Copy down the plus. Open bracket, perimeter of the cross-sectional area. This is the perimeter of the square, of the cross-sectional area. So we have 4 plus 4 plus 4 plus 4. And we need to multiply by the thickness. So if this is the cross-sectional area, this Z value, which we found to be 20 times 2, which is 40, is going to be our thickness. Key this in your calculator. 2, 4 times 4, plus 4 plus 4 plus 4 plus 4 times 40. And we get 672. Okay, so you have to show the working. I place the working on top so that it is easier, clearer for you to compare the numbers with the diagram. For you, when you do the working, you show it at the bottom where there is space. So part B is done. If you are a manufacturer, which packaging will you choose? If you are the manufacturer, you want to keep costs low. You want to spend as little money as you can. The more material you use, the more you have to pay, isn't it? The more paper you use, the more you have to pay. So you want to use the packaging with as little material as possible. Therefore, answer will be, I choose A. If they ask for Y, then you must say area for A is less than area for B. So it's cheaper. So I hope you are doing your corrections if you got any part of them wrong. Next, question 13. This time we have cookies. It is this cookie is a cylinder, radius of 4. So from the center to the top, that is 4 cm. The thickness is 2 centimeters. There are two ways we can pack the 20 cookies. Either you roll them up like this, like your Oreos or your digestive biscuits. You roll them up. Very little space wasted. Or we can put them in a box like this. Now in this box, we've got all these gaps over here. They are filled with air. Okay, so there are some wasted space over here. Packaging A is a closed cylinder. Closed means no holes. Both sides all closed. Diameter P. Length Q. Packaging B is a box. R by S by T. So find all these values. Let's start with P. For part A, if we know that the radius is 4 centimeters, what must P be? 4 times 2, or 4 plus 4, that's 8. So P equals to 8. Q, the thickness is 2 centimeters. We've got 20 of them. 20 times 2, and we get 40. R, we know the diameter is 8. From one end to the other end, that is 8. So this is 8 cm. It is the same 8 cm over here. We put them side by side. R must be 8 times 2, which is 16. S is this diameter, which is also 8. And T, 10 rows of cookies, 10 rows. Each cookie 2 cm thick, so it'll be 10 times 2. So here we have the value of PQRST. Next, part B, find the total surface area of the outside of each packaging. Same formula, I will repeat the formula again. It is 2 times of the cross-sectional area plus perimeter of cross-sectional area times the thickness. Okay, so let's start with packaging A. Area for A equals to, follow the formula, 2. Copy down the 2. 2 times cross-sectional area. Where's the cross-sectional area? This circle. What is this area of, what is the area of this shaded region? What shape is it? It's a circle. What is the formula for area of a circle? Pi r squared. So 2 times of pi r, radius is 4. Square. Okay, we got the first part done. 2 times of the cross-sectional area. Next, we need to add. See the plus over here? We add. We add the perimeter of the cross-sectional area. So open bracket, the perimeter of this red shaded region is shown here. So I've just outlined the perimeter. So this perimeter is also known as the circumference of a circle. What is the formula for a circumference? It will be 2 pi r, or some of you know it as pi d, where d is the diameter. Diameter is 2 times of radius. So 2 pi r or pi d, they are the same thing. Close the bracket. This is the perimeter. Now we need to multiply this by the thickness. The thickness is Q. Earlier we found that Q equals to 40. Now we're ready to calculate. Put everything into your calculator. 2, open bracket, I see a pi, put it in. 4, close bracket, square, plus 2 pi 4, 40. 1105.84. Okay, so 5 SF is enough. Obviously this value goes on forever and ever because there was a pi involved. So we leave it as 5 SF first. Later on we will round it to 3 SF. Okay, over here, 1110 square centimeters. This is the area for A. Let's continue with the area for packaging B. Area for B. Same thing, copy down the 2. Now we need the cross-sectional area. Can you shade the cross-sectional area? Since it is a cuboid, we've got 3 possibilities, but typically we shade the one in front. Take note, this is not just for the circle, it is for the entire rectangle. So the area of a rectangle given by length times breadth. So S times R. 16 times 8. 16 times 8. Plus perimeter of the cross-sectional area. Use the same blue color. This is the perimeter. So this is given by R plus S plus R plus S. 16 plus 8 plus 16 plus 8. Okay, this is 16 and this is 8, 16 and 8. After the perimeter, we need to multiply by the thickness. The thickness over here is the value of T, which is 20. So 1216. This is an exact value. There is no need to round off to 3SF. So we leave it as 1216. If you are a manufacturer, which packaging will you choose? Part C. What will you choose? I will choose A. Because it is smaller. It has a lower surface area. A large rectangular box has dimensions 8 cm, 9 cm and 6 cm to contain cubes with side 2 cm. Find the maximum number of cubes that the box can contain. So if we want the maximum, we have to try and squeeze as many as we can, and we're going to place them very neatly. This dimension, this length over here, we've got 8 cm. This is 6 cm. Okay, I'm just repeating the numbers. I'm going to try and find out how many of this 2 by 2 by 2 I can place at the bottom. So if the length over here is 8 cm, how many of the cubes do you think I can fit? 4. Yeah, okay, 4. 1, 2. Okay, divide it in 2 parts. Another 2. Okay, so I can fit 4 of them. Does the drawing make sense to you so far? Okay, what about on this side? If this is 6 cm, how many do you think I can fit? 3. So this is the outside view. Let me draw in the dotted line to show you what's actually happening. Okay, does my diagram make sense to you? Now we see that there is one layer at the bottom, right? How many cubes are there in this bottom layer? I didn't finish the drawing, but can you tell how many cubes are there in the bottom layer? If I were to finish drawing, this is what you should see. Okay, how many cubes do you see now? Bottom layer. 12. We get 4 times 3, right? That's 12 at the bottom already. Is Can I only fit one layer or can I go another layer? I can go another layer. Okay, let's go another layer. There'll be another 2 cm. I'm too lazy to draw everything, so only draw the front. So the second layer, how many cubes are there in the second layer? Also 12. Okay, first layer 12, second layer 12. What's the height currently? For 2 layers, what's the height currently? 4 cm. Do I still have space?
Yes.
Can I go another layer?
Yes.
Another 2 cm, right? So there's another 12 already. Can I go another level? Okay. Now I have a total of 4 levels. So for these 4 levels, there will be 8 cm already. Can I go another level? Cannot, because the cube has a height of 2 cm. So we have to stop at 4 levels. Refresh my memory, how many cubes are there in one level? 12. If I have 4 levels, what is the total? 12 times 4, right? That will give us 48. Okay, so the maximum number of cubes equals to, now we know that it is 12 times 4, but where did the 12 come from? It came from 3 times 4, or 4 times 3. Okay, that's the bottom layer, that's where we get the 12. Then we multiply this by the 4 layers, the 4 levels. And we get 48. Requires some visualization to see what's happening. But not tough, also not difficult.